Yeah, hi. In this video, I want to show you how to use Excel to do testing hypothesis. And basically, what Excel does is calculates the p-value. So this is for your lab 4. So we're going to start with large samples and look at, say, lower tailed, upper tailed, and two-tailed tests. So here the unknown parameter can be either mu or p. I just use mu here, but it works for both of them. So your alternative is mu less than mu 0, and so you need to calculate the z value, the test statistic value, by hand, which is x bar minus mu 0 over s over square root of n. And since we have a large test, that's a z value, and we don't need here to calculate critical value, but we only need to, once we get the p-value, we can do a testing hypothesis. So that's what we want to do here. So I want to put the value here. And basically this is my value, which is negative 1.68. I have a graph here that's going to be somewhere here, and the p-value is going to be the area under the curve and the lower tail here. So I go here and I click on fx. I want to go to statistical and look at the corresponding function, which you can see in the on the homework assignment, or if you read the PowerPoint presentations. So we're going to n normal ST distribution, which is the standard normal distribution. This is the one here, and my z value is negative 1.68, and I want to say true, TRUE, and that's going to give me the p-value immediately. If it's an upper tail test, and here is my upper tail test in this case, because this is larger, greater than value, but my value here is 1.76, so I can do this by using the same distribution, except I want to have my value 1.76 is going to be here, so my p-value is going to be in the upper tail. I can do that in two ways. One is to enter 1.76 in the same z function and then get this area and take 1 minus that, or I can just take the negative of this and use the symmetry property of the bell shape to get the p-value. So let me quickly do it in both ways. If I go here and put my equal sign, and I just recover my normal distribution here, and so that's going to be z equal, now I want to put the negative value, negative 1.76. It's true, TRUE, and there it is. So even though I'm looking at this area, but I calculated the corresponding area in this here, which is the same thing. However, if I wanted just to put 196, let me do that. Say put it here, and I go click on the function, or if I then I need to go to the normal, find the normal distribution now, and normal standard distribution again. If I put 1.76, put true, that's going to give me this value here, so I need 1 minus this to get this value. So basically what I did, I put 1.76 here, I got this area, but my p-value is here, so I need to take 1 minus that. Okay, so for my p-value in the two-tail test, I can just calculate the corresponding one the same as I did in the one-tail test and double that value. So it's going to be, so here I can go again, use the normal distribution, normal standard distribution, take negative 1.76 and say it's true, and so I get the same value here, but my p-value is going to be double that, so that's going to be equal 2 times the value I got here, and that should be my p-value. Okay. So if my sample is small, in this case I had a sample of 16, which means my degrees of freedom will be 15. My original population is normal with unknown variance, so that means I have a t-distribution now. The calculating the p-value is very similar, except we have to use the t-distribution instead of the uh, z-distribution. But we have different ways of doing this, so different students may do it differently. I just want to go over a couple of these. One is to use the t-distribution, which is in so this is a lower tail test. If I go up here and click on the function, now I'm looking for under statistical for the t-distribution, which is in your handout, would be the t, it's the t distribution, this one here. I click on it, so I need the value, which is negative 1.68, my degrees of freedom 15, and this is true, and that gives me the p-value. Basically, I have my t-distribution should be a little bit flatter than this, but if I put that negative 1.68 here, that gives me the p-value. In the upper tail, I can do the same thing. So in this case, I can use the same t-distribution function and put negative 1.76, so I can get the corresponding area in the lower tail. Or I can put the positive value, get the value here, take 1 minus that. Or in the case of the t-distribution, Excel has a special function for the right distribution. So in this case, I'm going to use that and go up and click on fx, go search for that function, which in this case would be the t-distribution. Let's find it. It's t-distribution RT, right, the right tail distribution. Okay, so in this case x is 1 point, so I don't need to put the negative value 1.76, and degrees of freedom are 15, and I don't need in this case to take 1 minus. It just gives me the value immediately. Okay? For the two-tail test, same thing. I can use either one of these functions and double what I get by using the value 1.7. So in this case, if I enter 1.76, I would have to double it because it's a two-tail. It's a two-tail test. That should be not equal here, and that should also, because it's a two-tail, should say not equal. So if I want the p-value here, again I can go and do any of those methods, but in this case the Excel has a special function for two-tail. It's called t-distribution 2t, which is this one here. So if I click on it and then I enter, in this case, 1.76, and the degrees of freedom are 15, and click OK, and you can see this value is double that value because we have the same test statistic value. Okay, so that's for calculating the p-values. And so of course in this case, if we look at these values here, 0.04 is less than 5%. So in this case we reject. For this one I would reject the hypothesis. For the two-tail is 0.07, so I would reject if my alpha is 10%, but I would not reject if my alpha is 5%, since this value is between 5% and 10%. Same thing here, that's about 5%. In this case I would reject, and in this case it's similar to the 0.07. So if I had a p-value which is say 15%, then I would not definitely reject. All right. Yeah, so one more thing, and this is the last question on your homework assignment, is how to find the critical values or the tabulated values. Of course, we can find those from the table directly, or we can find them from Excel allows us to do that. And in this case, to find critical values in a test hypothesis, if you remember, we only need alpha and whether the test is an upper tail or a two tail or a lower tail. So I know alpha is 5%. So I want to find the critical value for alpha with 15 degrees of freedom. I want to put the value here. So in this case, I go to the fx and I want to find the corresponding function for this, which is in this case going to be see t inverse. Okay, so this is going to be my t inverse. Click OK, and here the probability, so that's alpha 0.05 and the degrees of freedom is 15, and you can see here I got a negative value. Okay, so that negative value is, that would be my critical value for a left-tailed test. If my test is right-tailed, I just do the same thing, except I would remove the negative value. So I would use 1.75 as my critical value for a right-tailed test, because then for a right-tailed test I need the value to be in the upper tail. For a two-tailed test, actually I can either use half the alpha, use the same function and pick, instead of alpha 0.05 I'll pick alpha 0.025, or I can have in this case a special function, which Excel has a special function for us. If I go up there and click on fx, go to statistical and go down to the t. So I have here the t inverse 2t, and now my probability is 0.05 and my degrees of freedom are 15, and you can see here with the same 5%, I got a different value, which is 2.13, because basically what that function does, it takes the alpha I had here and splits it in half. Okay, so that gives me one value for the upper tail and it's negative for the lower tail. I hope this is helpful. Thank you.